Hi class, Mrs. Goodman here. Welcome to our videocast for lessons 2.1 to 2.5. If you do not have your graph paper and a pencil, please go and get those items right now. We are starting with lesson 2.1, which is comparing, ordering, and rounding decimals. And if we take a look at the example that you see for number 1, we are comparing 4 and 217 thousandths to 4 and 22 hundredths. Now, if you remember, in order to compare these correctly, we're going to set those up vertically, and then we have to add a 0 to the 22 hundredths so there are equal numbers of digits. We then compare from left to right until we find a digit that is different. And here it is the 1. And since that is the smaller digit, I would put the less than sign into that. If you look below, you're going to see an example for our rounding. And so number 4 asks us to round 35 and 165 thousandths to the nearest tenth. And so we write out that number and then we underline the one which is in the tens place. We draw our arrow to the 6, and since 6 is 5 or above, we know to take that 1 and round it up to a 2. So my answer is 35 and 2/10. Now remember, you cannot put any digits after the tens place when you are rounding. So make sure there are no digits after the place you're rounding to. Okay, go ahead and take your graph paper and do numbers 2, 3, 5, and 6. Pause the video cast while you do that, and I'll be waiting right here for you. Okay, welcome back. Let's take a look at number 2. When you set those up vertically, we had to add a 0 after our 51 hundredths, and when we compare from left to right, our digits are the same. So those are equal. For number 3, again, we want to line up our decimal point and then add a 0 after our 1,114 and 1/10. And if we compare from left to right, we see, wait a minute. Right here, this is my larger digit, so this has to be my larger number. For that reason, the less than sign would be correct. In number 5, since I am rounding to the hundredths place, I would underline the 6. I would look to the right. The 5, since it's 5 or greater, tells me to round that 6 up to a 7. And remember, no digits after the hundredths place. And then finally, in number 6, we're rounding to the ones place, which is our whole number. And so we're going to underline the 5. We look to the right. It's a 1, which tells us to keep that 5 the same. And that's going to give me an answer of 35. Finally, we are going to compare these numbers by ordering them from least to greatest. So pause the video cast, use your graph paper, do them vertically, and put these numbers in order from least to greatest. I'll be waiting right here for you. Okay, welcome back. When we do that, we write our numbers vertically. We make sure our decimal points are lined up. We add any zeros that we need to so there are equal numbers of digits after the decimal point. And then we compare from left to right. And here we see that the 0 is our smallest one. So I can get rid of that. Now, since the 2 3s are the same, I'm going to look here and see this 0 is the smallest, so that's my second one. The 3 and the 8 are different. Here's my smaller one, so that would be the third one. And then this is the fourth one. And when I rewrite those in order from least to greatest, that's what you should have. Okay, let's go on to lesson 2.2, which is adding and subtracting decimals. In order to do this, I want you to use your graph paper and remember our rules for adding and subtracting. Write the numbers vertically, lining up the decimal points. Add any zeros that you need to so they have equal numbers of digits. Add or subtract, and then bring your decimal straight down. You have 4 problems here. Can you pause the video cast while you do these 4? Okay, welcome back. Let's take a look at our first one. We should have set it up like this. Now remember, in addition, it does not matter which number you put first. Addition and multiplication are commutative, so we can switch the order. When I did that, I lined up my decimal points. I did not have to add any zeros, and I ended up getting 19 and 84 hundredths. Now in number 9, since I am subtracting, I notice that there's no decimal in my whole number, the 5. If there is no decimal, you must put it at the end of the number in order for it not to change that number. And so now when I set it up, It's going to look like this. Notice I had to put 2 zeros after my decimal point, so there'd be an equal number of digits after the decimal. And then when I go ahead and do my subtraction, I end up with 3 and 86 hundredths. In number 10, once again, I need to line up my decimal points. I need to add 2 zeros after the 11 and 2/10, so there are equal number of digits. And when I subtract those, I get 1 and 437 thousandths. And finally, in number 11, I want to add a 0 after the 3 and 1/10, and I get 21 and 89 hundredths. Lesson 2.3 was multiplying decimals. There are 2 problems here that I'm going to have you work out in just a minute. But let's take a look at, let's bring this to the front so you can see it a little bit more easily. Take a look at our rules for multiplying decimals. Remember, just multiply like they're whole numbers. Do not line up the decimal points. Don't add any zeros. Count the number of digits after the decimal point in each factor, and then move your decimal in the product that many places left. And then we always estimate just to check our answer. I also gave you a tip that if there's a 0 in the whole number position, you don't need to write that in your multiplication problem. It just causes extra steps for you. So go ahead, pause the videocast, and try these 2 on your graph paper. Okay, welcome back. Let's take a look when we set that up. Remember, we can get rid of these zeros. We multiply 2 times 7 and we get 14. I have 1 digit after the decimal point there, 1 digit after the decimal point there, so I move over 2 places and I put my 0 back in to get 14 hundredths. In number 13, remember I don't have to multiply with these zeros. When I do my first step of multiplication, I get 70. As I'm going to do my second step of multiplication now, remember I have to add this 0 to hold that place value so that I move over 1 place. Now when I count my digits, I have 2 digits after the decimal point in each factor, which means I'm going to move over 4 places. And you should have 1,190 10,000ths as your answer. In lesson 2.4, we divided decimals, and if we take a look at our steps for dividing decimals, remember we said to move the decimal in the divisor, if there is one, until it hits the wall. That's the same as multiplying it by a power of 10. We move the decimal in the dividend the same number of places, then bring it straight up, and then forget about your decimal. Divide as you would whole numbers, adding zeros if necessary, and then estimate using compatible numbers to check your answer. So I'm going to pause this for just a minute. Go ahead and work out these 2 problems on your graph paper. All right, welcome back. Let's take a look. In number 14, since we had a decimal point in our divisor, we had to move it 1 place over, and we had to move it 1 place in the dividend. Then we brought it straight up. Now when we begin our division, we could see the steps of division right here. If you did not get 2 and 48 hundredths, look at each step to see where your answer might differ. Remember, we do have to add a 0 on so that we can continue our division, because we do not use remainders when we're dividing with decimals. Let's take a look at number 15. Now notice in your divisor, you had to move the decimal point 2 places. We have to do the same in the dividend, move it 2 places. Bring that decimal point straight up into your quotient and then forget about it. Remember, you can knock off these zeros now and go ahead and do the division, and your steps should look like this. If you did not get 22 and 32 hundredths for your answer, look at each step and see where is yours different than the answer that you're seeing right here. Our final lesson was lesson 2.5, reading and writing in scientific notation. And we had 3 different things that we worked on. The first thing that we worked on was changing a standard form number to scientific notation. If you look at my example, 3,258,400, in order to write that in scientific notation, I put my decimal point between the first and second digit. Since there's no decimal in my number, I'm then going to count to see how many places did I have to move that decimal point, and I notice I had to move it 6 places, so that's going to be my exponent. I'm now going to write it without the zeros, but I do include all my whole numbers. So I knock the zeros off at the end, and I'm going to get 3 and 2,584 10,000ths times 10 to the 6th power. And remember, in scientific notation, we always multiply it times 10. We then move to changing scientific notation back to standard form. And to do that, we look at our exponent, which is a 2. And that tells us to move our decimal point 2 places to the right to make it a larger number. And then we rewrite that number, knowing that the decimal's no longer here. We write it as 834 and 5/10. And then lastly, we compared with scientific notation, and we said if the exponents are different, the larger exponent is your larger number. But if the exponents are the same, we had to write our decimals vertically like we did in lesson 2.1 and compare the decimals. The larger number there would then be the one that is greater. Well, you have 6 to try. Go ahead and pause the videocast while you work out these last 6 problems. Okay, let's take a look at how you did. If you are moving your decimal point to right in between the 8 and the 7, I've moved it 2 places. There are no zeros to knock off, so notice I leave in all of my non-zero digits. So I have 8 and 7,793 10,000ths times 10 to the 2nd power. In number 17, I'd place my decimal here, and I'd count how many places I had to move my decimal point. These zeros at the end of the number can be knocked off, so I end up with 6 and 21 thousandths times 10 to the 9th power. Now in number 18, when I'm changing scientific notation back to standard form, I look at my exponent 5, and I know I have to move this decimal point 5 places. Since I can only move it 2, I must add 3 zeros on to get my answer of 977,000. In number 19, since the exponent is an 8, I can only move my decimal point 1 place to the right, so that means I need to add on 7 zeros in order to get 120 million. Finally, in number 20, I look and I notice that these exponents, 8, are the same, so when I write my numbers vertically to compare them, I see that that would be my larger digit, and so the correct answer there would be that it is less than. And in number 21, since my exponents are different, I notice that this is my larger exponent, and so again, my answer is going to be less than. Well, I hope this helped you. Please make sure that you're doing some other studying for the quiz. See me if you have any questions, and good luck to you.